Okay, welcome to Note7.com. Call ourselves Note7 Creative Engineering. And so, what we try to do is look at principles that will aid you in being creative. And I'm going to explain some of the ways to get creative for yourself. Um, and one of the things is the reason Genesis 1:27 is posted is that's my favorite verse in the Bible. Uh, God created man in his image. In his image, he created male and female. Male and female, he created. It uses that word created 3 times. And if we're in his image, we can create. And in essence, that's what separates us from every other beast or animal on the face of the planet. Bees are still making the exact same honeycomb. Monkeys are still sticking in sticks and collecting ants. But humans, created in God's image, we can create, invent. It's awesome. Write music, poetry, um, video, internet. So this class is designed to help all of us break ourselves out of the mold and be able to push ourselves to a more creative place. Um, if you have any questions, comments, or things you'd like to see on the show, go ahead and email us, note7school@gmail.com, and we will answer your emails. Also, we ask a riddle at the beginning of every show, which I'm about to ask, and we never tell the answer on the show. You have to actually send in your answer. And because we feel like we're creative and you're creative, you may come up with answers we never even thought of. So everybody gets the correct answer, not correct, the answer we're expecting. We will post that. And if you come up with an alternate answer that we think is correct or better than what we'd expected, we'll post that under a different category. So the riddle today is we have to solve this seemingly simple problem. Okay? So one of the reasons we use riddles is the premise of a riddle is it brings you down a path of what you think is the answer, and it never is the answer. So by studying riddles, it will help you think past the path where everybody thinks they want you to go, where you're about to go, to step back and say, wait a minute, is that really the right answer? Is that really the best answer? Or is that really the only answer? So our uh, riddle today seems very simple. The square root of 25 minus the square root of 9. And what is the answer? That's the riddle. Now, the twist is that there is more than one answer. Okay? I'm not going to tell you how many answers there are. That's part of the riddle. So a lot of people would look at it. Some people don't know what a square root is. Most people here in this class know what a square root is. Very simple. If I didn't even pose it as a riddle, okay, you would swear there's one answer. That's why the riddle, and that's why we use it on this program, to show you that we need to be creative. Stand back. Don't look for just one answer. Look for multiple answers. Sometimes another answer may lead you a different direction. When you're inventing something, which I love to invent, and I hope you guys like to invent, and you're seeking for a patent, don't look around at what other people are doing. Focus on your thing. Once you start looking at somebody that's doing something similar, you'll head down that path. Don't tell people about the idea right away. Everybody will say, oh, I've already heard that, that's already done. About 80% of the time, that's not even true because they're not understanding. When you come up with a revolutionary idea, if there's 8 billion people on the planet, they're thinking, surely somebody's already done it. I've heard of something like that. That's almost never true. They're in their mind, they're just piecing a few puzzles together. I've already heard of a camera. I've already heard of, but that is not what you're proposing. So keep going, keep pushing the limits. Don't do outside research. Keep your mind creative. Even you going out and starting looking at stuff on the internet is going to be pulled the direction of something that's already done. So that's sort of my challenge for today. So that's a riddle for the day. It's super simple. Square root of 25 minus square root of 9 equals. And I've asked many math professors, and nothing against them, they come up with one answer only, and that's it. And it's only because they have not taught themselves to be creative. When you tell them the answer, they laugh, and of course they know that there are more than one answer, but they are so, like all of us, led down a path of least resistance. That's the answer, that's the end of it. Okay, so now we're going to get on with our lesson. We're going to, in each class, do a sort of a scientific, it can be math equations, it can be physics, it can be science, it can even be biblical stuff. And so we will be looking each day at things that seem simple, and they are, but how to use them in real life. So this is all real life application. So we all know a circle and a sphere. A circle is just a flat area of something, in this case a circle. A sphere is a real ball. The earth is a sphere. And so we're really familiar, everybody's familiar with pi r squared, okay? And that equals area, okay? So everybody's familiar with that. I'm going to teach you a different formula today that's not that, that's way more applicable to use in real life situation. So we'll start with that. We will also get to volume of not a circle now, this is a circle. A sphere is 4/3 pi r cube, okay? So anything that's area typically is a square. So you have the square feet of a house, that's an area. Anything that's volume is a cube, okay? So whenever you take feet cubed, that's a volume. So the volume of the water in your swimming pool. So volume is a tangible, physical, liquid or solid. Typically an area just represents a surface area. So first we're just going to focus on the area of a circle. Now, the other formula that we're not taught in school too much, but this is the one you need to start using, is pi d squared over 4, okay? Might seem more complicated at first, but pi d squared over 4. It turns out that when a radius is half of a diameter, so it's really a diameter over 2. When you square the 2, you get 4, and when you double the radius, you get d. So this is the exact same thing, and I want you to memorize this. This is what you're going to use in real life. We won't even talk about the sphere volume for now because this is so fun. So, real life applications. I'm a hydrologist. A lot of times we're designing pipe, size of pipe to carry water, usually runoff from storm drains, sometimes sewer, many times supplying pipe for water lines. So in the streets, for fire flow, we call it potable or potable drinking water. So real life situations, many times on my plans I'll specify two 24-inch pipes, two 2-foot pipes. So I've got two 2-foot pipes under, let's call it a driveway, okay? And the client builder is supposed to put in two 2-foot pipes. One of the things, first of all, is nobody ever talks about anything in terms of radius. When you order a pizza, if you're ordering a 12-inch pizza, you don't say, I'd like a 6-inch radius pizza. When you order pipes, you don't say, I'd like a 1-foot radius pipe. So radius out of the real world doesn't even really exist. We talk about diameter. And so that's why this is critical. So when somebody says I put in two 2-feet pipe or 24-feet pipe, then they said that's what you called for. But I decided I'm going to put in 4 12-inch pipes. It's the same thing. All right, here's this is a 2-foot, so here's a 1-foot, here's a 1-foot diameter, and here 1 foot and 1 foot. Knowing this formula, it turns out when you compare A to B, everything crosses out. So if you were to say, let's just take a 2-foot pipe, 2 foot squared, that's the diameter, 2 foot squared, pi, and then over 4. So this is this. Here's what they put in, okay? They put in two 1-inch or two 1-foot pipes. So you divide that by pi, diameter, 1 squared. In this case, they put in two of them, so we'll multiply it times 2, okay? And divide by 4. So what happens is these all cross out. So all you really need to know is d squared over d squared, okay? So in this case, 2 times 2 is 4, so it simplifies. We've got 4. 1 squared is 1, okay? And then there's two of them, so that's 2. So they put in, this will hold 2 times more than 2 4-inch. So the net effect is 2 squared is 4, 1 squared is 1. That's what you compare. You overlay them, and now a 2-foot pipe holds 4 times what a 1-foot pipe is. And now you can do this quickly. When I'm ordering a pizza and I have a 12-inch for $10, or let's call it a 18-inch, that's pretty big, for $15. So 1 squared, 12-inch, is 1. That's all I need to know. And 1.5 squared is 2.25. So I quickly take the 12-inch pizza, 1 foot, the 18-inch pizza, 1.5 feet. 1.5 feet is 2.25. 1 foot, diameter 1. All the diameter, pi, everything crosses out. I quickly know that this is 225% larger pizza than that for $5 more, 50% more. So you always get the large pizza anyway, that's the end. But this helps justify it. So you can quickly take the diameter of this squared, the diameter of this squared, put one over the top of the other, and figure out the deficiency, whether they're equal or which is greater. So that is the rule of area. And please start thinking in terms of diameter. R is not even a real thing in the real world. Everything's measured in the diameter of a pipe. PVC, 1-inch, 2-inch, 4-inch, sewer pipe, 8-inch, 10-inch, 12-inch. We're going to go with that. That, I think, is enough of that class with that. Now, the crazy thing is volume. You thought that whole thing with diameter squared is bad? Wait until we hit the volume. So I won't go into the whole formula for everything, but basically you've got the volume, which is based on 4/3, okay, pi r cube, okay? So there's another formula, I'm not going to get to it, but it ends up being d cube, okay? And then everything else crosses out. So to make this class short, when we compare volumes, you can just take d cubed. Because once again, nobody's saying my radius of my sphere is 1 inch when you have a 2-inch ball. You're saying I have a 2-inch ball, a 1-inch golf ball. We talk in terms of diameter. So the same thing, forget the whole formula before and after. For comparison's sake, I have the volume of a 1-inch diameter ball and a volume of a 2-inch diameter ball. That's what I want to compare. So how that applies if you were in manufacturing and you wanted to know, instead of making 1-inch balls, how much more material do we need to make 2-inch diameter balls? Okay, that could be a fair thing. So then we know how much to charge, how much rubber to order. So it turns out 1-inch diameter ball cube, 1 times 1 times 1 equals 1. Okay, 1 cubic inch. Okay, inch to the 3rd. I love units, always carry units. That helps solve most of your problems. Now we have d3 of a 2-inch. So now we have 2-inch cube. So guys, what's 2 times 2 times 2? 2 times 2 is 4, times 2 is 8. Very simple, right? But who would have guessed in a million years that a 2-inch rubber ball takes 8 times more material? I'm going to tell you, I had a 2 Christmases ago, I was going to make meatballs for this potluck dinner I was going to, and I thought I was going to be really fancy. And I had about 2 pounds of meat, hamburger meat, and I was going to make meatballs. And I said, well, why would I want to make 1-inch meatballs? I'm going to make 2-inch. Everybody loves 2-inch more. Well, look, I quickly put this in my formula, and I had about enough meatballs, meat to make 24 1-inch meatballs. Well, I threw this in my mind, and I thought, wait a minute. 24-inch, 1-inch diameter meatballs, if I make them in 2-inch, it's going to only yield, divide that by 8, it's going to give me 3 meatballs. So literally, 24 1-inch meatballs fit into 3 2-inch diameter meatballs. I know it's hard to believe, that's why it's fun, that's why it's science. When we get into the volume of spheres, and you can only imagine when you get into the sun versus the earth, you may at first think, well, we're not going to do sun versus earth, but if this diameter is 10 of something, 10 miles, 10 inches, 10 feet, and this is 1 of something, okay? So this thing is 10 times bigger diameter. Well, 1 times 1 times 1, that stays 1 cubic, whatever it is. Let's say it's cubic miles, okay? Now, 10 times 10 times 10, that's 100, okay? That's 1,000, okay? This one equals 1,000 cubic miles. This isn't 10 times larger. This is 1,000 times larger. So when you get to the size of the sun, you respect it more because it's to the cube root. They may say it's this big in diameter and this big in diameter. That doesn't tell the whole story. In this case, oh, this is 10 times bigger. No, the diameter is 10 times bigger. It's 1,000 times bigger. 10 times 10, 100, times another 10, 1,000. And so I'm trying to use simple, dumb this down. And when I say dumb it down, so that we can quickly calculate things, because I love to dumb things down, so we just say, doesn't matter the units, 1 times 1 times 1, feet, inches, miles, 1 times 1 times 1, or 10 times 10 times 10. That's just a comparison, okay? So that's the lesson for today. And I usually give the application at the end, but when it comes to pizzas, I had to jump ahead a little bit and tell you how to order a pizza. And for manufacturing purposes, this is fantastic. It's the same thing. For some reason people are blown away when you do a sphere. But if you do a cube, it's the same thing. A cube being basically what we would think is a box. And if you've got 1 times 1, 1 width, 1 height, 1 depth, somehow we're not amazed. But it's the same principle. I didn't draw it bigger. I should have, just for comparison's sake. If this is 2 by 2 by 2, everybody knows how to calculate a box. 1 times 1 times 1. This is 1. Let's say these are feet. 1 cubic foot. Okay. 1 times 1 times 1. 1 times cubic foot. Ft to the third. 2 times 2 times 2. That's easy. That's 8 feet cubed. Same thing. 1-inch box. 2-inch box, 1-foot box, 2-foot box. This holds 8 times more. And so for some reason in our minds we can rectify a cube because we understand a box and it's simple math. But it's the same principle whether it's a sphere or a box, because volume is a cube, which is a cube, foot cube, meters cube, area is a square. So exponentially, this goes up much quicker. Okay, it's a lesson for today. Again, if you can answer the riddle or have any questions or don't like what we're doing, tell us that too. We'll change something maybe for you. Note7gmail.com. If you want to check out our website, note7.com, all our lessons. This is only the second lesson, are posted. And we hope you enjoy the show. And see you again next time. Thanks. Bye.